I welcome you all in this session. Today, we will discuss construction of deterministic finite automata that accept set of all strings over A and B of even length and odd length. So first, we will see construction of DFA that accept set of all strings over A and B of even length. So first we have to find the sigma, that is A and B, and here we have to accept empty string also, and all the strings of length 2, 4 and so on. So our language L will be infinite. So now we are going to construct a DFA that will accept empty string, and it will accept strings of length 2, strings of length 4 and strings of length 6 and so on. Simultaneously, it should also reject input string of length 1, 3, 5, 7 and so on. So first, in order to accept the empty string, we should make our initial state as final so that it can accept the input string of length 0, that is empty string. And we have to make the next state as non-final so that on input string of length 1 will not be accepted, like this. Now for input string of length 2, either we can add more state like state C, or we can make DFA like this, because if we try to add more state, the number of state will be infinite. So in this way, we can limit the number of states that can accept the string of even length. So this will be a minimal DFA. We can cross check it. So first, on input string of length 0, that is empty string, it will be accepted because the initial state is a final state. On input string of length 1, the next state will be B, and it is not a final state. So all the strings of length 1 will be rejected. Then the input string of length 2, the next state will be A, and A is a final state. So it will be accepted. Now again, if the length of the string is 3, then on input either A or B, the next state will be state B, which is non-final. So again, the string of length 3 will be rejected. And the next state for the input string of length 4 will be state A. So the string of length 4 will be accepted, and so on. So this DFA will accept empty string and all the string of even length. Now we will see construction of a DFA that accepts set of all string over A and B of odd length. So first we will find the sigma, that is A and B. Here we do not have to accept the string of length 0, that is empty string. Here we have to accept strings of length 1, 3, 5, 7 and so on, like this. And here our language L will be infinite. So for now here we will try to make a DFA that will not accept the empty string, that will not accept the strings of length 2, 4, 6 and so on. And it will accept the string of length 1, 3, 5, 7 and so on. So here we have not made the initial state A as final, so it will not accept empty string. We have made the next state B as final, so it will accept a string of length 1 and it will not accept any string of length 2, but again it will accept a string of length 3 and so on. So this DFA is a minimal DFA and it is satisfying all the given criteria. So this is all from my side for today's session. Thank you for joining.